Okay, in this part of the lesson, we're going to look at operations with complex numbers. What's nice is I think these operations are actually usually easier to carry out than they would be with normal radical problems, right? Because that's what imaginary or complex numbers are. They're a subset of radical problems where you're taking square roots of negatives. But what's nice is the variable, well, I shouldn't say variable, the constant I, which represents the square root of -1, acts like a variable. So for example, we're going to just do a couple quick probs and show you how they work. If you have the complex number, let's use it again, 5 plus 2i, and you add to that the complex number -3 plus 4i. What you do is you just add like terms. So we're going to say, let's take the 5 plus the -3, that is 2. And then we're going to take the 2i, and we're going to add to that the 4i, that adds up to 6i. And there's your answer, and there it is in standard form too, 2 plus 6i. Now with subtraction, same thing. So if we had, say, -7 minus 6i, and we subtracted from that -2 plus 3i. We just have to be very cautious with our negatives. So again, grouping. Like terms, -7 minus -2. Minus a negative's plus, so that would be -5. And then we have -6i minus positive 3i. -6 minus 3 is -9i. Now on that last one, perhaps you'd like to maybe use some distributing to write it out a little different. And we can do that, right? So here's a little more detail on that one. We can drop the parentheses on the first one, -7 minus 6i. We can distribute this negative. That's plus 2. Now that's minus 3i. And then what's really happening is we're regrouping. We're saying I'm going to take -7 plus 2. There's the -5. And then I'm going to take the -6i, or minus 6i, minus 3i, and there's the -9i. So there's the details on that one. So adding and subtracting, relatively straightforward with complex numbers. We'll look at multiplying now. So multiplying, when we multiply complex numbers, they act just like binomials. So if I have -6 plus 5i, and I multiply that times 2 minus 3i. We're going to do, I'm not always a fan of this acronym, but I learned it this way, and probably a lot of you have, is FOIL. So we're going to take the first times the first. -6 times 2 is -12. First times the second is what I usually say. So -6 times -3 is positive 18i. Remember, it acts just like an x. 5i times 2 is 10i. And now we have to use a little more caution on this one. 5i times -3i. Well, 5 times -3 is -15. And you have I times I, that is I squared. We're going to get to that in a moment. We can usually combine like terms. So we've got a -12, we've got 18i and 10i, that is 28i. But over here, I squared, if you remember how we defined it in the previous video, we said I squared is equal to -1. Because what I represents is a number times itself that's equal to -1. So what we're saying is, right there, that's a -1. You have 15 times -1, that's -15, but you're subtracting it, so that becomes a plus 15 right there. So in essence, what happens is if you're adding a term that's got an I squared attached, you're going to add the opposite of that. So now I can continue to combine like terms. -12 plus 15 is 3, and if we put it in the order of standard form, we have 3 plus 28i. I have one other thing up here, conjugates. We'll look at conjugates here. Conjugates are pretty nifty, very easy to identify a conjugate. And I'm going to actually do it with a binomial here that's not complex, just to remind you or give the idea. So if you have x plus 2, the conjugate of x plus 2 is x minus 2. What a conjugate is it's the same expression, binomial, but with a different sign in between. So plus to minus, minus to plus. So with complex numbers, if you have, say, 2 plus 3i, the conjugate would be 2 minus 3i. something really nifty happens when you distribute conjugates. So we'll do it with our binomials. We're going to multiply them. We're going to multiply down here too. X times x is x squared. But what happens is, I say if you are a FOIL person, you have negative 2x and you have positive 2x. They cancel each other out. Then you have 2 times negative 2 is negative 4. And you might remember that from your distributing your factoring days, that x plus 2 times x minus 2 is x squared minus 4. Let's see what happens with the complex numbers down here. So I'll take 2 times 2, that's 4. I'm going to write it all out this time. I have 2 times negative 3i, that's negative 6i. Then I go to 3i times 2, well that's also 6i. So like above, the oi part of the FOIL cancels out. And you can just skip that if you know you're multiplying conjugates. Then we have 3i times negative 3i, and that's minus 9i squared. Well look, there's that I squared again. I squared is equal to negative 1. So this really is just, instead of 4 minus 9i squared, it's just 4 plus 9, which is 13. So conjugates have this really unique and neat feature with complex numbers that when you multiply them, they turn into real numbers when you do that multiplication. So kind of cool. And what they do is they actually follow the rule that goes with the binomial rule from above, and that's if you have a plus b times a minus b, it's always a squared minus b squared. So here, you right away could say, well, I know it's going to be 2 squared minus 3i squared, and you can simplify from there and get the same result. We're going to see a little more with those conjugates in an upcoming part of the lesson. One more thing I want to mention about operations. Problems like this. The square root of negative 4 times the square root of negative 16. It's very tempting to just say this is the square root of 64, which is 8. And the reason you say that is because there is a rule with radicals that states if you're multiplying two radicals with the same index, you can just multiply what's underneath. That's true, okay? But there's a catchphrase or a catch-all to that. Sorry, there's a condition to that multiplication, and that is that the radicands, what's underneath, have to be greater than 0. So that 2 has to be positive, the 3 has to be positive, and it works. Point being, when we're dealing with imaginary numbers, we have to make them imaginary first, then carry out the operation. So what I wrote up here, no good. So what we want to do is we want to say the square root of negative 4. Well, the square root of 4 is 2, but since it's negative, that's imaginary, so it's 2i. The square root of negative 16, well, that's 4, but since it's negative, it's 4i. Then we can multiply. So we want to do any simplification first, including simplification of the negatives for imaginary numbers. Now multiply, that's 8i squared, but I squared is negative 1, and so it is negative 8. And if you think about it, since imaginary numbers are existing such that we can multiply two things to get, like say, negative 1, I times I, that would mean if we multiply any two imaginary numbers, we should be getting a negative real number out of that then. That's it for operations, and we'll look at some other features in the future.